Hello everyone. In this video we're going to go over using a C program to blink an LED on and off on the Raspberry Pi. In some previous videos we went over the first application where we made a C program that printed hello world to the screen. And we also went over in our libraries video a little bit about libraries and how to install the library we're going to use in this video to access the general purpose I/O of the Raspberry Pi. And so let's go ahead and get started. Before we get started with the actual C program, first let's go over the hardware configuration. So on the Raspberry Pi website, you can get access to the schematic, which will show you the pinout for the 40-pin header that's on the Raspberry Pi. And this is a very typical schematic for a connector for any circuit board. And just if you haven't looked at many of these before, this box here is labeled J8, and that is that represents the connector that we're actually plugged into on the board. Now connectors have pin numbers, and those are the numbers that you see here. So they're numbered 1 through 40. So each pin of that connector has a number associated with it. Now somewhere along the line, those pins are connected to other places on the board, and that's what these are here. So all these names here, GPIO 14, GPIO 15, and so on, those are actually names of pins that are on the BCM 2835 processor. So those are pin names for the main processor for the Raspberry Pi. And you'll notice that on some of these there's also some names in parentheses, and those are other functions of those. So some pins of the processor can be configured to do more than one thing. They can only do one thing at a time, but in setting it up, you can for example use this is the pin we're going to use here. It's pin 12 of the connector, and it's connected to GPIO 18 of the processor, but it can also be used as Gen 1, which is a pulse width modulator. Okay, so that's the schematic, and for this video we're going to be again connected to pin 12 of the connector, which is GPIO 18, and that's what we're going to use it as, the GPIO 18. And over here you have I have a picture of this actual circuit, and I'll so you can see that actually this is a breakout board that I got with a kit with the Pi I'm using here, and I actually give a review about this kit on my website, and I really like it, and I think it's a good deal if you're going to do much work like this. Go ahead and get the kit. So this has markings on it, and these markings here, I think I found that they correlate to more of this naming convention here. So you can see that we're on pin 18. This is GPIO 18 with one end of this wire. And then the other end of this wire is plugged in over here. And if you've never seen one of these things before, this is a breadboard, or sometimes called a solderless breadboard, because you don't have to solder anything. And I explained how all these tie points are all tied together. I explained how that's done over on my website under the tools of the trade. But basically, so just try to follow along with it. So pin 18 here is all of these right here are connected together, and so this is technically connected to pin 18. Then down here, this wire is underneath here connected to this side of the LED, And if you haven't used LEDs before, the longer these two terminals, if you look at them when they're straight, one will be longer than the other. The longer one goes to the positive side. And we won't get too far into that, but this value right here is a disconnect. So there's no connection between here and here, only through this LED. And so the other end of the LED is connected over here. And then there's a resistor in here. And this resistor is in place to limit the current. I have another video that I'll post up here on actually on my website. I talk about Ohm's law and what this resistor is. You can go to my website to review Ohm's law and what it does, but mainly what this is here for is to limit the amount of current flowing through here so we don't damage anything. If we didn't have this resistor in here, it might work, but we're at risk of causing some damage. And this is a 220 ohm resistor, and you can tell from the picture here, you should be able to tell this is a red, brown. Red correlates to a 2, and this would be another 2, and then brown correlates to 1, so it would be 2, 2, and then 1, 0, so 220 ohms. Right here is this resistor, and the other end of this resistor is tied into here. All of these are tied together, and it goes back to ground. So here we have our GPIO pin through this jumper wire, one side of the LED, other side of the LED, through a resistor, and then to go back to ground. So that's the circuit we're going to use in this tutorial. Next we'll go over the actual program that's going to turn this LED on and off. Okay, so one of the secondary things that I'm going to show you a little bit about in this video, besides blinking the LED on and off, is use of comments in C programming. There's two ways to add comments. One, I show you how to use both of them here. One is to use this / asterisk, and then everything in between that, and then the asterisk, and the next asterisk, and / just like this. Everything in between is a comment. That's one way to do it. Or you can just use 2 slashes, and this comment's a single line. This kind of comment can comment multiple lines, like you have up here. I have this starts the comment right here, and this ends the comment right here. And neat thing that you can do with this type is I can minimize that just to clean things up. And this just demonstrates comments are not part of the actual program. So when this compiles, these are not comments will not increase the size of your code that actually goes on the finished program. So use comments prolifically. Basically, make sure that your comments are useful for documenting the code, and make sure that you absolutely will be able to understand the code from your comments 6 months or 6 years from now, when you need to change it a little bit to do something else. So make prolific use of comments, and I can't overemphasize that. So I'm just going to roll those up a little bit. And so the first thing we're going to do in the program and the actual C code itself is we're going to include the library that we downloaded previously. So we have the BCM 2835.h header file here, and we hit its pound include and then put that in there. Now if you want to go look at that file, you can highlight it, and we're doing this in Geany here, and right click, and you click open selected file, and I've already done that over here, and we'll get into that a little bit later. And next we're going to define a constant, and we're going to define a constant called LED, and that's what we're going to flash on and off. And if you want to dig into what this actually means, though, we're defining it as this right here, this name, which comes from the this BCM 2835 library, and we can go find out what that means by looking at that library. I've already done that and brought it up. Here we go, and highlight it. It's on this line right here. So this is a enumeration, and you can see that here it's just equal to 18. So in reality, we could replace this with 18 in our code, but we might not know what 18 means. And in fact, up here, he leaves a comment that you can just use the numbers instead of the symbolic names. But later on, I'll show you where we use it, and I'll let you decide which you like better. Okay, so as we've stated in a previous video, every C program has a main function. So our main function starts here. And the first line of real code that gets executed is going to be this if statement here. And don't worry about if you don't understand what if statements are, don't worry about it. We'll go over that in a future video. We're going to use the same program for a lot of different things and kind of modify it as we go to demonstrate different things about programming C. And so what it basically does is it initializes the library that we're going to use, and that's just another way of saying it's setting up our options, or it's configuring registers for the processor. Remember when we were talking about the schematic, certain pins can do different things. Well, this line is basically calling a function that sets those settings, and if it does what it's supposed to, it returns a value and it allows us to continue. If something goes wrong, then it exits the program. So that's basically what this line does. We'll get into that in more detail in future videos. The next one, and I don't want to skip these. So there's a different kind of comment here. You just do the forward slashes. Notice that I don't have the option to roll these ones up though. Those are single line comments. You can also put those comments at the end of a line like this. Yeah, so your preference. The next line we need to do here for our blinking LEDs, we need to set that pin. Remember, it was pin 18 or pin 12 of the actual connector. We need to set it to as an output. And that's what this function does. And we can go into the library here, or we can go to the website, the support website for the library, and we can find out what this function actually does. But for right now, just trust me that what it does is it sets the pin 18. See we're using LED right here. And let me roll this up right here. So remember, I said we could replace this with 18. So this represents 18, which then makes this represent 18. And so we could put 18 here, and this code will work exactly the same. But I think it makes it easier to read to say that we're going to actually put the word LED in here, because that's what this program is doing. And it's going to set the direction as an output. Okay, so that line sets the pin 18 to an output. Next, I'm going to define a variable, and this is how you define a variable in C. First, you have to state the type of the variable. It's something you don't have to do in Python if you've been programming Python. We actually have to tell it what kind of variable is, and we're going to make this an unsigned int, and we're going to call it delay, and we're going to assign a value 1000. And that's because there's a function that we're going to call, and it's down here on this line right here, called the BCM 2835 underscore delay, and it's expecting an unsigned int value. And again, you can find out what that function needs to accept from the BCM 2835 support website, or you can look it up in this over here. We could find those functions right here. So right here, let's see, what did I say? Delay right there. See that function right there? So we can go to that right there, and see this is what it says. It needs an unsigned int, and it's millis. That's the name of it, but it accepts milliseconds. Oh, there it is in the comments there. Millis delay in milliseconds. Go back to our program, and so this function down here, and don't worry if you don't know what I mean by function. We'll get into functions later. It basically says that this thing is going to go delay the program. It's going to wait for amount of time defined by delay. And up here, we're making this variable named delay equal to 1,000. So down here we're saying wait 1,000 milliseconds or 1 second. Okay, getting ahead of myself a little bit. Next line of code is this is a what's sometimes called an infinite loop or a forever loop. There's a couple different ways of doing it. This way, again, we'll get into loops later. This is while the condition in these parentheses is true, this loop is going to continue to run. Okay? And true also equals 1. So if we put a 1 in there, this is always true, and it will always loop. Okay? And next line here, there are two other functions we're going to call. This function here, we can go to the support website to find out what it does and what it expects, or we can go to the this source file. But it's going to set the our pin that we defined as LED. Again, we could just put 18 in there, so it's going to set pin 18. And set is another way of saying 1, or set it to high or on. So 1, high, or on, or sometimes you might use true. They all basically mean the same thing. Down here, it's the BCM 2835 underscore GPIO underscore clear. Clear is another way of saying 0 or low or off or false. Those terms are synonymous in many programming situations. So we're turning it on, and we're turning it off. And I already went over the delay function. In between turning it on and turning it off, we're waiting 1,000 milliseconds, and which equals 1 second. Now, if I run this, actually, yeah, let's go ahead and let's build first of all. So it's finished, and I'm going to turn my camera on and wait 1 second. Okay, I have my my camera on now, so you can see this when it runs. And I'm going to go ahead and hit run here. And you should see now, you can see that the LED is blinking on and off about 1 second in between the flashes there. Now, if we wanted to, let's go ahead and just stop this for now. And I stopped it while it was on, and it stays on, and we'll take care of that later. We can go ahead and we can change this. Let's just change it to 100. Okay. Now it's only going to wait 100 milliseconds between going on and off. Again, let me do this. Let me just hit run again. You can see that nothing changed. That's because I didn't build it. It's still running the original program before I made that change. I'll go ahead and turn this off again. You can see that time I turned it off when it was off, and it stayed off. I haven't built this yet, so the program that's running is actually still thinks this value is 1,000. You actually, if it happens, you just have to make sure that you build it after you make changes. Now, if I hit this again, it's flashing much faster. You can see that's going there like that. Okay, but there's one thing I forgot to show you, and it has to do with setting up your compiler. I'm gonna, before I do that, I'm gonna no, that's not what I want to do. Let's build this. I'll make it so the light turns off. There we go. All right. There's one thing I forgot to show you. If you just followed along and you haven't done anything with your build settings or your build configuration, it won't compile because this is Geany is a relatively bare bones type IDE, and you need to tell it where to look for. You actually need to tell it that you need to include this library. So under build, set build commands, and there's three things that I did from the standard. When you get this, this will not be in here. So by default, this will not be there, and that will not be there, and this will not be there. So this is what it'll look like right out of the box if you haven't changed it yet. Okay, and now if I hit build, I'll get these warnings down here. Okay, and it's basically it's thrown up all over these things called BCM 2835. It doesn't know what I'm talking about because I haven't told it to go get that file. To change that, we can go ahead and go back up into build, set build commands, and it's a -L BCM 2835. Yeah, I think that's it right there. I don't think we need the H. It's -L BCM 2835. And down here we're going to put sudo. I don't know if you can hear that, but my dog is pawing at the door behind me. Not subo, it's sudo down here. Okay. And now if we build, it builds just fine. You see? So again, so let's try one more thing before we go. Remember how I said that up here we could just replace all this with 18? Let's just go ahead and do that. First of all, let's try it like this. Let's just put 18 here. Okay. And let's build it. Okay, and now let's go ahead and run that. Ah, look, it still works. It still works just like it did before. Okay, and so we don't even need this anymore. We could get rid of this completely, and down here, wherever it says LED, we just put in 18. 18. 18. And 18. Now this program will still work. I hope. Okay, built, and yeah. See, the program's still doing the same thing. So you can see there's usually more than one way to write the program, but I'll leave it up to you what you like better. Do you like to see the number here, 18, and just look at your schematic and know that that means that that's that pin 18, or would you rather put a name in there that's more meaningful? It's up to you, whatever you think is going to make it easier for you to understand the code. Let's go ahead and get rid of delay. In my first video, I was talking about how to, how Python and C compared. And one of the things I did is I showed you how fast it could switch on and off a GPIO, and this is how I did it. This is almost exactly the same code. It basically took the delay out and just flashed it on and off, on and off. And you notice how I just used comments to get rid of that code. And I think I did it up here as well. So that's another use of comments. If you want to just change a code temporarily, maybe take a line out or put a different line that's very similar and then disable the old line, you can do that and you can switch back and forth easily without having to rewrite the code. So now I'm going to build this. I'm going to show you what happens on the output here. Okay, let's run that. You can see that the light, you can just see a little bit of a flicker, but it's, but that's it. So that's turning the LED on as fast as it can. And you can see down here that the processor was working at full capacity there to turn that on and off. So that's about it. We've turned the LED on and off with the general purpose I/O of the Raspberry Pi. We've used the library, and we've used comments, and we've used a couple different functions, including the delay function. And in future videos, we'll go over a little bit more about some of the things we used in this video, like the if statements and loops, and actually a little bit more about variables and stuff. So check back or subscribe, and we'll go over those things in future videos. If you like this video, please click like. It motivates me to make other videos just like it. If you want to find out when I post more videos, please subscribe. You can also read about completed projects on our website, spaztech.net or spaztech.com. On our website, we include details of how we did some of the projects that are on these videos and some of the source code that you can use yourself as much as you like. If you want to track progress of projects we have going on step by step, be sure to check out our pages on Twitter and on Facebook.